Yeah. Hello, everyone. Today I'm going to explain the transaction management, which is fourth unit in our DBMS subject. Okay. So I'm sharing the slides. Just check on this. Yeah. First is, first let us know what is transaction. Okay. So transaction refers to the execution of any one user program in DBMS. That means, see here, trans this is a multiprocessor. Here multitasking, multiprocessing will be happening in our database management system. Okay, so multiple transactions will be taking at the same instance. Okay, so one transaction refers to the one user program. Okay, so if I want to perform any program, I want to perform any task, okay, then my task, my only task will become a single transaction. Or you can also define it as a transaction can be defined as a group of logical tasks being executed. Okay, or else you can also tell it as a set of logical instructions that has to perform some task. I repeat again, it is a set of logical instructions that has to be performed. Okay, so you can define transaction in this way. And another definition is transaction is nothing but it is an event that has to be occur, and this event contains either read or write options. Okay, the read and write operations. Along with that, we'll see other two operations will be there in the transaction. So there, after getting the operations which are in the transaction, we can define the better transaction definition there. Okay, so when a transaction is happening in a database management system, okay, in order to ensure the consistency in the database, every transaction has to follow some properties. Every transaction has to follow some properties. Those properties, they have coined it as acid properties. Okay, so acid properties are nothing but A stands for atomicity, C stands for consistency, and I stands for isolation, and D stands for durability. Okay, so I repeat again, why to ensure this property by transaction means in order to maintain the consistency and completeness in the data, okay, about the data in the database, the every data should have some consistency and every data should be complete. Okay, so to ensure these two features, okay, every transaction has to follow this four acid properties. Okay, so acid properties means atomicity, consistency, isolation, and durability. Okay, so when a transaction is following these four properties, we say that there is a consistency in the database. Okay, the meaning of consistency is correctness. Okay, consistency means correctness in the database. Okay, so there are no faults in the database due to our transaction, so we need to maintain that uh, correctness. Okay, now let us discuss one by one about this acid properties. Okay, so the first and foremost properties that has to be followed by a transaction when it is executed is atomicity. Okay, so atomicity is nothing but in simple state, in simple lines, either the complete transaction should be done or none of the instructions in the transaction should be done. Okay, so I repeat again, either the transaction should be fully executed or neither of the instructions in the transaction should be executed. Okay, so I'll read out these definitions here. See, it also mean the same. See, this property states that all of the instructions within the transaction must be executed or none of them should be executed. Okay, so yeah, just now whatever I said, the instruction should be either completely executed or none of the instructions should be executed. Okay, or else you can also say it as this property states that all the transactions execution must be atomic. Okay, that means all the actions should be carried out or none of the actions should be executed. Okay, and so we'll see what are the other operations which involve in this. Okay, so first we'll discuss about atomicity. atomicity property. Okay, the meaning of this property is either see, we have already discussed the definition of the transaction. Okay, so the definition of the transaction is it is a set of logical instructions, or else it is a set of read and write operations, okay, which perform certain tasks. Okay, now when a transaction has to follow the atomic property means, see here, whatever the set of logical instructions present in the transaction are there. Okay, so all those transactions, the sequence of logical instructions, okay, should be followed one by one from the top to bottom. Okay, it should start the transaction and it should end the transaction. Okay, so this is one way. And another way is, if the transaction has been stopped in the middle, okay, then the transaction, the consistency of the data will be gone. So to make sure that the data should be consistent, what we are doing is the transaction should be completely executed from top to bottom. That is a set of logical instructions present in the transaction, or none of the instructions should be executed. Okay, so to ensure this atomicity, we are having two operations. Okay, those two operations are abort operation and second is commit operation. Okay, so commit operation is nothing but the transaction has started and successfully completed and it has come to the end. Okay, so the changes made by this transaction to the database is permanently changed in the database. Okay, yes, I repeat, the meaning of commit in transaction indicates we have executed the transaction successfully, and due to the changes due to this transaction are completely modified in the database too. See, the meaning of transaction is it is set of logical instructions which is performing some actions. Okay, so the actions may indicate the actions may also perform some changes in the database. Okay, so these actions are reflected in the database whenever the commit operation is done by the transaction. Okay, so in simple terms, I'll read out this. See here, if a transaction commits, the changes made to the database are visible. That means whatever the changes are made by this transaction are visible in the database. That means the changes made due to this transaction are changed in the database also. Okay, so this commit is when the transaction is successful. Now, the second case of transaction is if the transaction has been stopped in the middle due to some failure. Okay, so it may be any kind of failure, lack of resources, or it is not getting the inputs from the other transactions, or any system failure. Okay, so these are n number of things where there may be a transaction failure. Okay, so now the commit was when the transaction was successful. Okay, second, the abort, we'll discuss about this abort. Okay, so abort function is whenever the transaction is stopped due to any system failure. Okay, now whatever the changes that are made, that has to be made to database with the help of this transaction are are not being done on the database. Okay, yes, I repeat, see here, the transaction, whatever the changes that has to be done to the database, okay, those are not changed in the database. Okay, so whatever the changes that has happened up to the system failure, okay, they are rolled back. Okay, that means they are aborted. The changes are not reflected in the database. Okay, so the simple thing is atomicity means the transaction is either fully executed or neither of the transaction should be executed. Okay, so these are ensured by two operations. Those two operations are abort and commit. If the transaction is successfully completed, then we write the commit. Okay, commit operation. The commit operation indicates that whatever the changes that has happened with the help of transaction are reflected in the database. Okay. Now, abort means whatever the changes that has happened up to the transaction before the system failure, those those changes are not visible in the database. That means the changes are not done in the database. Okay. So the changes are aborted. Okay. So database does not get affected by this abort statement. Okay. Only after the commit statement, the transaction changes are reflected in the database. Okay. Now, let us see this with with the help of a simple example. Okay, so let us consider a transaction which is containing two T1 and T2 other two transaction. Okay, so here our task is I have to transfer money from X to Y. Okay, I'm transferring 1,000 rupees from X to Y. Okay, so see here it is here it is clearly mentioned before the transaction X is having 5,000 and before the transaction Y is having 2,000. Okay, now this is our transaction. Okay, this transaction is containing two tasks again in a T1 and T2. Okay, so I'm reading the value of X. It is initially 5,000. Again, I'm reading the value of Y. It is 2,000. Now, what is our task? X has to debit 1,000 rupees from X account and he has to credit it to the Y's account. Okay. So our task is we need to reduce 1,000 rupees. This is arithmetic operation that has to be done. Okay. So X is reduced by 1,000 rupees and the same time Y should be credited with 1,000 rupees. Okay, so now I need to write to the database. Okay, so whatever the X value now, before the arithmetic operation, X value was different, and after the arithmetic operation, the X value was different. X value is different. Okay, so we need to write it to the database. So I'm rewriting the X value. Okay, so in the same way, before the arithmetic operation, Y value was different, and after the arithmetic operation Y value is different. Okay, so again we are doing a write operation. Okay, so we are rewriting this Y value. Okay, now this is about the transaction has been finished. Okay, now after the transaction, what are the values here? X is having 4,000 and Y is having 3,000. Okay, now, so this is the example. So our example is we are taking one transaction which is having two accounts X and Y. So here we are reducing 1,000 rupees from the X account. That is, we are debiting 1,000 rupees from the X account and we are crediting the same to the same amount to the Y's account. Okay, now see here, this if we consider this as a transaction, here we have two different cases. Okay, while the transaction is performing, we are having two different cases. One is the transaction is completed successfully. Okay, and the next case is if the transaction is failed due to some system failure or whatever it may be. Okay, now see here, if we doesn't know the property of the atomicity, what happens, let us see. Okay, again I repeat, if we doesn't know the property of atomicity, what happens, let us see. Okay, now if the transaction fails after the completion of T1 but before completion of T2, so see what is T1, reducing the amount from the X account. Okay, so what is T2, crediting the 1,000 rupees to the Y's account. Okay, so see here, the task T1 is debiting the 1,000 rupees from the X account. Task T2 is crediting the 1,000 rupees to the Y's account. Okay. So here, see here, if this transaction fails after the completion of T1, T1 has been finished. That means 1,000 rupees has been deduced from the X account. Okay. But before the completion of T2, here T2 has not been started or not been completed. Okay. That is after write and before write of Y. So we have written we have changed the modified the value of X, but T2 task has not yet been started. Okay, then the amount has been reduced from X but not added to Y. So see here, the amount has been reduced from the X account, but it is not added to the Y account. So where are these 1,000 rupees? So 1,000 rupees. So after this transaction, what happens? X values will be 4,000, but whereas Y value will be only 2,000. Okay. So with this, what is happening? There is an inconsistency in the database. Okay. So this we call it as inconsistency in the database. Okay, see, actually, before the transaction and after the transaction, the data should be matched. Okay, there should be consistency in the data. If 1,000 rupees is debited from the X account, it has to be credited to the Y account. Okay, so that is a reason. That is a reason. In the transaction, the complete instructions should be executed, or else neither of the instructions should be executed. Okay, so o- o- we have seen if the transaction fails, how inconsistency, how data is leading to the inconsistency. Okay, so to ensure that the database should contain only the consistent data, okay, we are following one of the properties of transactions. Okay, so that the primary property and one of the properties of transactions are atomicity. Okay, so in simple terms, atomicity is nothing but either the complete transaction should be executed or the transaction should not be executed. Okay, so this is atomicity. Now next is consistency. Okay, so there should be consistency in the database. Okay, so the meaning of consistency means the data means we should not lose any value or we should not gain any value due to the transactions. Okay, so due to multiple transaction or a isolated transaction, whatever the type of transaction it may be. Okay, see, if I'm having an account, okay, I am doing multiple transaction. Okay, as I am doing multiple transaction, it should not lead me to the inconsistent data. Okay, so how many transaction I'm going to have, whether it is a single transaction or multiple transaction, or else I'm doing multiple transaction with any other account, okay, repeatedly, whatever it may be, how many transactions it may be, the data should be consistent. It should lead to the consistent data, not the inconsistent data. Okay, so how many may be the transaction, but the data efficiency and the quality of the data should be maintained in the database. Okay, so let us see the definition here. The database must remain in consistent state even after performing any kind of transaction, ensuring the correctness of the data. Same thing. Okay, so how many transactions it may be done. Okay, whatever the kind of transaction it has undergone. Okay, whatever it may be, but at the end of the transaction, the correctness of the data should be there. Okay, so this is the another property of the database. Oh, sorry, transactions in the database. Okay, so or else we can also define it as, if we execute a particular transaction in isolation or together with other transaction in multi-programming environment, the transaction should give the same result in any case. Okay, so just now what I have said, that is a definition. Okay, so whatever the kind of transactions, either it may be multiple transaction or it may be single transaction. Okay, so see here, in nowadays everything is a multi-programming environment. Okay, so not only a single user, multiple users can post the queries. Okay, system has to serve, or an application has to serve with a multi-programmers, or we have multi-users for single applications nowadays. Okay, so whatever it may be, how many users it may be, a single user or multiple user. Okay, so after the transaction, the data should remain consistent in the database. Okay, now next is, yeah. Each transaction run by itself with no concurrent execution of other transaction must preserve the consistency of the database. Okay, so whether it is a concurrent executions or what kind of executions it may be, even though we should maintain the consistency in the database. Okay, this property we'll call it as the consistency. Okay, so and the user is responsible for this consistency property. Okay, now let us see one simple example. Okay, same example which sorry, same example which we have taken it for the atomicity property. Okay, so let it be the same example. X we need to debit 1,000 rupees and we need to credit 1,000 rupees to the Y's account. Okay, now before the transaction, these are the values 5,000 and 2,000, and during the transaction, these are the operations. We are reading the value, we are doing a computation on that account, again we are rewriting the value. Okay, same thing in the task 2. We are reading the value, we are doing the computation, that is arithmetic operations on Y's account, and we are updating the value of Y. Okay, now after this transaction, these are the values. Okay, X is having 4,000 rupees and Y is having 3,000 rupees. Okay, now how we will check the consistency in the database means, see here, if a transaction is going to take place, okay, transaction is neither reducing the amount or crediting the amount. Okay, I'm crediting some amount from my account and I am debiting some account from my account and crediting to some other's account. Okay, so this is what actually happens in the transaction. Or else debiting some account from the X database, okay, X account, and crediting to me. Okay, so whatever it may be, whatever the values, whatever the money, okay, I want to debit or credit, okay, it is within these two accounts. Okay, see, if X is reduced by 2,000, it has to credit 2,000 to Y's account. Or else, if Y is debiting 1,000 rupees from its account, it has to be credited to the X account. If not, the consistency will be lost. Because see, if Y is reducing, that means debiting 1,000 rupees from his account, and he is no way crediting to the other's account, who is losing in the at the end? So Y is losing his money. 1,000 rupees money is lost by Y. Okay, so we make sure that the first property, atomicity, that means in the transaction, the complete transaction instruction should be executed. Okay, or else neither of them should be executed. Okay, if the transaction is successfully completed from for starting point to the end point, okay, then there is less chance of consistency. Okay, and how we recheck whether the data is consistent or not is, see here, before the transaction, what are the values of X and Y here? So X is having 5,000 and Y is having 2,000. So sum it up, what we'll get? We'll get 7,000. Okay. Now, after the transaction, check what is the value of X? 4,000. And after the transaction, what is the value of Y? 3,000. Okay. Again, sum it up. What will get? 7,000. Okay. So before the transaction, what was the summation of two accounts? It was 7,000. And after the transaction also, if you sum up X and Y, what we are getting? 7,000. That means we are neither getting money from the other's third account, or we are neither losing single NP from our account. Okay, so before the transaction, when you are summing up the two accounts, that means between what the transaction, between which two accounts the transaction is being executed. So sum up the values in those two accounts, it gives some value. And after the transaction also sum up those two accounts, okay, it gives the same value which is before the transaction. Okay, now if we get the same value before the transaction and after the transaction, when you're summing up the two accounts, then we say that this transaction is consistent, it is maintaining consistency in the database. Okay, this is clear. So this is about this is about consistency property in the database. Okay, so in simple terms, consistency means before the transaction, how consistent the data is. After undergoing multiple transaction or single transaction, or whether it is a complicated transaction, whether it is an easy transaction, whatever the kind of transaction it is going to take place, the data should maintain the same consistency how it is maintained before the transaction. Okay, so that is simply about I'm sorry, consistency. Okay, so next is isolation. Okay, so isolation is here, we'll discuss in deeper. Okay, so here isolation means, um we have already discussed the transactions. There will be a multiple transactions, okay, which are executed concurrently. Okay, the meaning of concurrently means, for example, in our real time, for example, if you are we are taking one app. Okay, so those application is used by multiple users. Okay, so the single application has to serve multiple users at the same time. Okay, so in the same way, database has to serve multiple transactions at the same time. Okay, so multiple transaction at the same time. Okay, it seems to be like same time, but it is not exactly at the same instance. Okay, so at an in single instance, okay, CPU can serve only single transactions. Okay, so we discuss all this scheduling kind of topics in operating system. Okay, so uh, for as of now, what we discuss is the transactions will occur concurrently. If multiple transactions are there, they execute concurrently. Okay, means they multiple transaction execute at the same time. Okay, now when multiple transactions are executing at the same time, what happens here is we will be having a problem for the resources. Okay, see here, every transaction needs some resources. Okay, for example, we have seen in the before example, we have taken two accounts data. Okay, we are reading the value of X account and we are reading the value of Y's account also. Okay, this reading the data of X account is a resource for this transaction. Okay, now reading the data of Y is resource for this transaction. Okay, so in such a way that we'll be having some n number of resources depending on the transaction. Okay, now these resources has to be shared among this multiple transactions which are executed concurrently. Okay, now which transaction should be given access to the resource and which transaction should not be given to the given access to the resources. Okay, those all things are taken care by the DBMS. Okay, and one more thing is only one transaction can access the shared resource at the same time. Okay, that means the same resource cannot be accessed by multiple transaction at the same time. Because why we should not access at the same time means, see here, for example, see simple orally I'm telling one example. uh, there are three transactions that has to be that are executing concurrently. Okay, so transaction T1, transaction T2, and transaction T3 are the three transactions that has to be executed concurrently. Okay, so during this concurrent execution, the task of T1, T2, T3 are: T1 has to uh, uh, debit 1,000 rupees from X account. Okay, now T2 task is it has to multiply 2 times of its existing amount. Okay, so T3 task is it has to add 1,000 rupees to the X account. Okay, so in the three transactions, the first step is we need to read the value of X value. Okay, we need to read the value of X in order to reduce the amount or credit the amount, or in order to in order to make double of that amount. Okay, whatever it may be. So the first thing is we need to read the value of X. Okay, now if X value is read at the same time by the three transactions, let us suppose if isolation property is not there. Okay, now initially the X value is 100. Okay, X account value is 100. Okay, now this 100 has been read by all the three transactions at the same time. Okay, now what is the task of transaction T1 task is it has to debit the 1,000 rupees from X account. Okay, the transaction T2 task is it has to multiply the whatever amount is there, multiply by 2. Okay, now the T3 transaction is it has to increment 1,000 rupees to the X account. Okay, now if X value is accessed at the same time by this three transaction, okay, at the end, what will be the X value? See, for example, if T2 task is performed first, if the T2 task is performed first, that means it has to multiply it by twice. Okay, that means so the account value becomes 2,000. Okay, and if T3 performs next, after T2, T3 performs next. Okay, now the value becomes 3,000. Now after T1, then lastly T1. 3,000 minus 3,000 minus 3,000, so 3,000 minus 1,000, then it becomes 2,000. Okay, so if the if the schedule is like T2, T3 and T1, then the value of X finally is 2000. Okay. Now, for example, if we follow T1, T2, T3, what happens? See here. T1 initially X is having 1000 rupees. Okay. What T1 is doing, it is debiting 1000 rupees from it. Okay. So if we debit 1000 rupees from it, what happens? It is becoming 0. Okay. So 0 twice means 0 double means again it is 0. So after T2, T1 and T2, what is the accounts of X account value is 0. Okay, now that X value is read by T3 account and it adds 1000 rupees. So now the value of X becomes 1000. Okay, so with this, what happening? See, depending on the sequence of the transaction, the values are changed. Okay, so which is not maintaining the consistency in the data. Okay, so this is a simple example where if there is no control on the resources, this is what happens. Okay, so that is the reason why database has to give permission to the only single transaction at a time. Okay, whenever there are some shared resources, okay, those resources should be allocated to the transactions properly. Okay, that means at one instance only one transaction has to access the resources. Okay, now after releasing the control on these resources, then other transactions should let the access the resources. Okay, so this is the reason, to ensure the consistency in the database, we should follow this isolation. Okay, so see here, this property ensures that multiple transaction occurs independently without leading to the inconsistency of the database state. Okay, so we are letting multiple transaction to execute, okay, without leading any inconsistency in the database. Okay, so transaction occurs independently without interference. That means no two or more transaction will interleave with each other. Okay, so all the transactions are independent of each other. Okay, yeah, change occurred in particular transaction will not be visible to any other transaction until that particular change in the transaction is returned to the memory. That means, for example, see here, see, T1 is doing T1 is undergoing certain task. Okay, T2 is also undergoing some task. Okay, until and unless T2 commits, okay, then the values changed in the T1 will not be visible to other transactions. Okay, so before commit, whatever the changes you have done to the transaction, due to transaction, whatever the changes done to the database are not visible to anyone until and unless the transaction is commit. Okay, then only the changes are visible to the other transactions. Okay, yeah, see here, we are achieving isolation through locking mechanism among shared resources. Okay, so we'll be having so many locking techniques, okay, on the shared resources. We'll be seeing in the further lectures, okay, which is again a very big topic. Okay, locking mechanism is again a very big topic. It contains several subtopics also. Okay, so this is how we are achieving isolation. Okay, see here, let us consider T and T double dash are the two transactions. Okay, so here reading the value of X, and you increasing the value of X. Okay, next writing the value of X, again reading the value of Y, again you're reducing 500 from the Y's account and writing the Y. Okay, so in T double dash we are reading XY values and we are summing up the X value and Y value, and we are giving it to the, we are updating it to the Z account. Okay, so here the problem is, see here, X value is changed in transaction T. Okay, and Y value is changed in the transaction T. Okay, now what should be the T dash, T double dash? What should be the resources that should be given to the T double dash? Whether the modified X value or the before the transaction, what is the value of X? Okay, same thing. You're reading the Y value. Okay, whether it is original Y or we are reducing 500 from the Y's account. Okay, so what values has to be taken? see, until and unless this T writes the commit here, these changes are not reflected on this T double dash. Okay. So this is how the transaction isolation is maintained. Okay. So next is durability. Okay. So durability is nothing but the same thing, whatever we are discussing right now. Okay. Until and unless the commit statement, the commit operation has come, okay, the changes are not done permanently to the database. Okay. So the transaction, due to transaction, whatever the changes are there, okay, those changes are not reflected into database until and unless the commit operation has been encountered by the database. Okay. And another thing is, by any chance, due to any system failure, or power failure, whatever it may be, the data should be in such a way that if the complete data should be recoverable. Okay, see here, I'll read the statement. This property states that once after the transaction is completed, the changes that are made be that made should be permanent and should be recoverable even after system crash or power failure. Okay, so this database has to be kept multiple copies. Okay, multiple copies of database has to be kept. Okay, and whatever the changes that are happening in the original database should also be done to the multiple copies. Okay, so that if one due to system crash or power fluctuations or whatever it may be, if we lose one database, okay, so we should be able to recover with another database also. Okay, so this is durability. Okay, this property ensures that once the transaction has completed its execution, the update modifications to the database are stored in and written to the disk. So once the commit has been done, all the changes that are made in the transaction, okay, whatever the instructions, due to what instructions the values have been changed, those values are reflected onto the disk. Okay, those values are permanently stored in the database. Okay, so and this they should persist even after system failure occurs. Okay, so even after system failure also, we should be enabled to recover the data. Okay, recover the consistent data even after the system crash. Okay, so this is all about the properties of transaction. Okay, so we call it as, this is the most of the expected questions in the end exams. Okay, so they tell that write the acid properties of transaction or else properties of transaction. They may they may they may mention the acid properties or they may not mention the acid properties, but if you see the properties of transaction, then it is acid properties. Okay, so acid means atomicity, consistency, isolation, and durability. Okay, so these are the acid properties. Okay, now whenever the transaction follows all these four properties, then we say that the transaction is maintaining consistency. Means due to this transaction, whatever, if because of this transaction, there is not much effect on the database. Okay, so it is performing its actions, and the actions are reflected in the database based on the transaction status. Okay, if the transaction is successful, the changes are made in the database. If the transaction is not successful, those changes are not reflected in the database. Okay, so this is all about properties of transaction. Thank you.